So uh, we go to question 2B, because the other parts are not in our coverage. So 2B is an identity. 2B1, prove that sine 2x plus sine x, if you divide it by 1 plus cos 2x plus cos x, you actually get tan x. So to prove this identity, we actually start from the left. So we start from the left. We pick the left-hand side and say, so this is sine 2x plus sine x divided by 1 plus cos 2x plus cos x. Okay. So now we start with the left-hand side. We know that sine 2x sine 2x is actually 2. It's 2 sine x cos x. Since it's coming from the identity sine A plus B, which is sine A cos B plus cos A sine B. So if where there is A, if where there is B, we put another A, we do A plus A. This will be sine A cos A plus cos A sine A. And so you see that this will be sine 2A, giving us 2 sine A cos A. So that's why we are saying sine 2x is the same thing as 2 sine A cos A. So that there now we have plus sine x in the numerator. And then down, where there is cos 2x. So cos 2x is actually cos squared x minus sine squared x. Also, it's coming from the same identity. If you do sine A, cos A plus A, you discover that you're having cos A minus sine A sine A. So those are compound identities. So this means that from the numerator, as you can see, sine is appearing twice. So we may decide to factor out sine so that we remain with 2 cos x plus 1. And in the denominator, where there is sine squared, so you see what we have up there is 1 plus cos squared x minus sine squared x. So if we choose to write this thing, so I'm thinking whether it will work direct or we need to.
Sorry, sir. Where has the cos x gone? The one under the original question.
Okay, thank you. It's here. Good. So it was actually disturbing my proof here. So I was checking where because I was also looking for the same. So this part we have in the denominator. If we write it as cos squared x plus 1 minus sine squared x plus cos x. From the master identity, remember that this is just cos squared. So now we have cos squared x plus cos squared x plus cos x. And these two can be added to give us 2 cos squared x plus cos x. And if we factor out cos x, we'll have 2 cos x plus 1. So when we go back there, we're going to write this as cos x 2 cos x plus 1. You see? So that this part and this part cancels, and then we remain with sine x over cos x, which is equal to tan x, which is our right-hand side. So I have come back to just put this factorized thing because whatever work I was doing, it's on the same page. You see? It's on the same page. So all my workings are on the same page. You see? I'm trying to justify whatever I've used here. Whatever I've solved, I solved on the same page. So if you solve on a different paper, then you need to bring back the work on the paper that you're submitting. But if you solve on the same paper, it's visible. So we can easily see that, oh, this person was working from there, and this is how they have arrived at that part. And that's why they're using it here. So when looking at identities, you just need to have an open mind. Okay, be ready to use anything that you can remember. So like here, cos 2x, sine 2x. So we had, because it's a combination of single sine and single cos, so we had to break those double ones into the single ones. And so you could see now the relationship that is there. Okay, so part 2 is saying, find the limit as x approaches 0 from right of 1 over x minus 1 over x squared. So you may wish to pick the limit as x approaches 0 plus after you combine the two. So you pick x squared as a common denominator, and then you have x minus 1 there. So if you think of this as a graph, you may be aware that this is a rational graph whose the horizontal asymptote is the x-axis, and the vertical is also the y-axis. And then when x is equal to 1, we have privileged to have the graph crossing. And when x is 2, the graph is positive and negative in this region. So we have a graph look like that. And so you are told to get the limit as you approach from the left. So if we approach from the left, from the right, it means you're going to use this kind of a graph. And so we see that it's going to minus infinity. So the idea of solving here may not be that much important because solving such a question is very complicated. Because I can't substitute 0. I can only understand what happens as I get closer to 0. And one way of analyzing such, since we're exposed to rational functions, is by having a sketch and see what is happening. Okay. So we move to question C. C is not part of the thing. So we'll go to question 3. Question 3a, we are told to sketch f of x is equal to, hello.
That's the way you answer question, the one you're from answering.
That's one of the ways.
Oh, that's one of the ways. But I don't understand. I'm not understanding. I don't know.
So where do you think the problem is?
On the second step,
On the sketching.
yeah.
What happened to the cos x in the denominator? Oh, okay, that one we answered it. All right, okay. So here, so what we did here was to get the common denominator between x and x squared. And then we simplified this to a fraction. We have used all the properties of sketching the rational graph. We got the vertical asymptote to be the y-axis, horizontal because of the powers to be the x-axis. Thereafter, we've sketched only on the right of this. And the question is saying, find the limit as x goes to 0 from the right. But this is 0 that we cannot touch. But as we get closer to 0, the curve is going down to minus infinity. So our job is just to look at where the curve is going. And that's how come we have said the limit then will be minus infinity. Because we have no way of substituting numbers. That's why I've opted to go for the graph because they have that skew.
All right, sir. Thank you.
Okay.
Sir,
Hello.
why is the graph there crossing the horizontal asymptote?
Because of the x that is in the numerator. I hope you haven't forgotten that we said if there is x in the numerator, you always equate the fraction, the numerator part to the horizontal asymptote to see if there's any injunction.
I only know that the horizontal asymptote isn't it that is to look at the degree of the numerator and you also compare it to the degree of the denominator.
That is how we find it.
Then yes, then the vertical now is the one that we equate the denominator. So we also like taking into consideration the numerator.
When the horizontal asymptote is equal to 0, and the numerator has a variable, you equate the numerator to that horizontal asymptote, which is 0, and see if it's possible to have it 0. And for sure, when x is 1, we're going to have 1 minus 1 over 1, which is 0 over 1, which is 0. So at such points, the horizontal asymptote is crossed. And that's why it has been crossed there.
Okay. I've learned this. This is new.
Okay. People who can say new should, I don't know which group they belong. Not the group you are coming from.
Are you sure?
Yeah, let's go to this question. It says, state the period, amplitude, and phase shift. So how do you find the period? You divide 360 by what? You say
2.
360 divided by B. And our B here is 2. So we get 180 as our period. The amplitude, the absolute of -1, which is positive 1. The phase shift, we equate 2x minus pi over 3 to 0. So that x is equal to pi over 6, which is equal to 30. That's the phase shift. Okay. So if you can't see what I'm writing, at least you can hear. So we have found the 3 things that are asked: the period, the amplitude, and the phase shift. The second part is saying sketch. Okay. The second part is saying sketch. So we need to sketch that function there. So remember, when you're asked to sketch, you need to get one more thing: the scale, which we said is period divided by 4. So in this case, it will be 180 divided by 4, which is equal to what? 5. Okay, so we go straight to the graph. The lines can't be straight. The WhatsApp. Let's try again. All right. At least it's not new. So we do that. Okay. Then we go to the phase shift. We have found 30 as a phase shift. So we write 30 here and start adding the scale. So 30 plus 45, we get 75. 75 plus 45, we get what? 80, we get 120.
Sir,
Hello.
if you are not given the interval, you start with the phase shift on your values of x that you're going to put on the x-axis.
Yes.
So if there's an interval, you start with the interval. If there is not, you start with the phase shift.
Exactly.
Okay.
And when you start from the first shift, you only need 4 extra numbers. So we had the first shift, then we have 1, 2, 3, 4 more. Then we are done. Because there's no interval, so we just sketch one complete oscillation.
Sir,
Hello.
sorry for disturbing. I saw someone that was talking like instead of adding the scale to the phase shift, you are adding the phase shift, like the phase shift. Then if they get another again, they add the phase shift. So it's a bit just confused.
That one I don't know. I've never seen such a one who adds the first shift. So I will reserve my comment. So now, then we pick the first number, 30, and take it in the function where there's x. So we know that the inside of the function is going to be 0 at the first number. Because when you put 30 there, you're going to have 60 minus 60, that is 0. Remember, pi over 3 is 60. So you can actually write this function. You say 2 minus sine 2x minus 60. You can do that. Okay. Minus 60. So you can do that. So now we substitute. So we have 2 minus sine 0. Like that. Then, so what is sine 0? Sine 0 is 0. So there we get 2. So we have at 30, we get 2 there. And then substitute the next value. That is 75. So we get 2 minus sine 75 by 2 is 150. 150 minus 60, that is 90. And sine 90 is 1. So we have 2 minus 1, which is equal to 1. Yeah. So we put 1 there. And then, so we have a point there. Let's do this. Okay. Then we go back. So the next number will take us back to 2 for sine. So we skip it. We go to the fourth number, 165. So 165 by 2 will give us will give us what? So 165 by 2. That's 0, 2, 3.
330.
Yeah, 330. So 330 minus 60. What do we get? Is it 330 or 320? Yeah, 330. So minus 60, what do we get?
270.
We get 270. So what is sine 270? Sine 270 is -1. So we have 2 plus 1, which is equal to 3. So this guy gives us a 3. So we put a 3 here. And then we stop solving now. We have found the 3 values. So this one will just give us back 2. So we have the sketch there. So when I'm using the angles, you know, I just calculate 3 angles. So if it's sine, I'm a bit smart there, because instead of solving for all these first 4 angles, I'll solve the first, the second, and skip the third. Because I know that the third will give me the same value as the first one. So I'll solve the first, the second, and the fourth. Then the fifth again will give me the same value as the first one. So I have my sketch like that. But for cos, you just substitute the first 3 angles, 30, 75, 120. It will give you 3 different values. Then going forward, you stop solving, just put back because they will now start repeating. Status. I thought maybe I wanted to ask a question. Okay. So if you check out, B was out of this coverage. So let's go to C. C is saying there's some binomial thing given here, x minus y over x to the power 6. So if the term independent of x in the expansion of that is 68, find the value of y. So if the term in the expansion so if the term in the expansion of that okay. I'm doing wrong with difficult to teach. Okay. So I thought that the term in the expansion of that is 68. Take one. For the previous page. Okay. It's here. New screenshot.
Hi, thank you. It's done.
Okay. So here we're told that if the term independent of x is 68, let's find the value of y. So as what we do is we'll solve this question as if we are finding the term independent of x. Using the formula NR A n minus r dr. That is where there's n, we put 6, and then we don't know what r is. Where there's a, we have x to the power 6 minus r, and then we have minus y over x to the power r. Now we are talking about x. So if you're talking about x, it means that we should put the x's together. So write this as x power 6 minus r minus y power r, and then x power minus r, like that. Because x is coming from the denominator. So then we concentrate on just x. So pick the powers of x. Since x, we have 6 minus r and x minus r. We want it to be equal to x power 0. So we pick 6 minus 2r and equal to 0, so that we have the value of r to be 3. Okay. So we'll go back and say, okay, this means that we now have t r plus 1 equal to 6. R is 3. Okay. And then we have, so bring it here. Okay. So we know that when the x's are put together, the power will be 0. So we just remain with minus y to the power 3, like that. Now we're told that this whole thing is equal to 68. The question says, if the term independent of x is 68, find y. So when you work out this, the answer should be 68. That's why I've get it into 68. So now what is 6 choose 3? 6 choose 3 is 6 factorial over 3 factorial by 3 factorial. Okay, that is 6 by 5 by 4 by 3 factorial over 3 factorial by 3 by 2 by 1. And so these will cancel. Then the 3 and the 2 take away 6. So we have a 20 from there. So minus 20y power 3 is equal to 68. When you divide by minus 20, you divide by minus 20. So we get y3 is equal to, we divide by 2 in 68. What do we get? We get 34 over 10. We get 34 over 10. We divide by 2 again. We get 17 over 5 minus. So this is minus 17 over 5. So meaning that y is going to be the cube root of minus 17 over 5. Like that. Ruthie.
Sir, I have a question. Like here where you wrote x to the power 0, isn't x to the power 0 equal to 1? But you put equals to 0. So I was wondering how.
So look, this one we had x to the power 6 minus 2r is equal to x power 0. Having 0 as a power means that the term we have won't have x. The question is saying, if the term independent of x is equal to 68, find the value of y. So we correct all the x's and make sure that the power of that x is 0, because if the power is 0, then our term won't have x. So as you can see that this term here doesn't have x, this term here, because the power of x here is 0. That's when it becomes 1 in this case. So here we are forcing it to become 1. That's why we have put the power to be 0. And so we have equated 6 minus 2r to 0 to make sure that the power of x is 0.
All right, thank you, sir.
Okay. Okay. So
So you only use this formula you've used if they've said it's independent to x. I don't know if it's for x or independent to x. That's when you use this format.
So if they say the term independent of x, then we use that.
Okay, sir.
Or if they ask you to find any term, you use that formula, except that if the power they mention is not 0, they can ask you to say the term in x4, like what they asked those guys in 1100 test. They said the term in x power 4. So when you reach there where you get it to 0, you would have get it to 4.
And then,
So,
sir, if you equate the x to 4, meaning the 4 will also be added to the the 4.
We don't equate x to 4. We equate the power of x to 4 if they tell us to find x in power 4.
Sir, you can just transform the question.
Hello?
You can just transform the question to that in 1100, then we solve it.
Okay,
We see how it goes.
okay, when we come back. Because we only have like
Okay.
seconds. So wait
Okay,
for
before
is there an emergency?
what goes wrong if you use the RSTM formula?
If you use the
RSTM formula, the one for n r minus 1, n choose r minus 1,
no,
r,
it's the same.
the same thing.
Yeah,
But
you get
there
the same.
on your final r, you get what? You still get the 3.
Yeah, you still get the 3.
Okay.
Yeah. Okay, so wait again for 10 minutes and come back. So the speed is a bit slow. Maybe it will help someone. When we are slow, I think we understand better.
Yes.
All right. Let's wait for 10.